Today we're getting into 12.9, walking away from graphing, at least kind of. Talking about our inverse trig functions. Might want your unit circle today. We've dealt with inverse trig in certain circumstances before. Talked about it way back in 12.1. What is the purpose of inverse trig? What's it solving for? Inverse just means opposite. The opposite of trig. It undoes trig. It undoes trig in order to solve for what types of things? Oh, I heard it. Starts with an A. At least I thought I heard it. Not. It does not solve for asymptotes.
Angles.
It solves for angles.
Oh.
Specifically, it solves for angle measure. Because when it comes to trig, you always have to do trig of an angle when you are working with trig. So, with that, we've got a bit of a problem though. We're going to find the exact value of the following. We're going to start with sine of 3 pi over 4. How do I find the exact value of sine of 3 pi over 4? Look at the unit circle, find the angle 3 pi over 4, and look where? The y value. At 3 pi over 4, sine is equal to square root of 2 over 2. What if I want to do sine of negative 5 pi over 4? It's negative 5 pi over 4 on the unit circle. No, it's too small. I don't have negative angles on the unit circle. So I do what? I find a coterminal angle by adding 2 pi to that angle. Negative 5 pi over 4 plus 2 pi is like negative 5 pi over 4 plus 8 pi over 4. Just got a common denominator because 2 pi was over 1, so I multiplied both top and the bottom by 4, and I get 3 pi over 4. Could I have also used a calculator to find the coterminal angle? Yes, just don't put the pi in. I would have done negative 5/4 plus 2, simplified the fraction, it would have told me it's 3/4. So, sine of negative 5 pi over 4 is equivalent to sine of 3 pi over 4, which we already found to be root 2 over 2. What about sine of pi over 4? Root 2 over 2. I purposely chose ones that sine of an angle equaled the exact same thing because this points out a big issue that comes up when it comes to inverse trig. And the issue being this: when it comes to doing inverse trig, if I'm working backwards, I would be doing inverse trig on the square root of 2 over 2 in order to find the angle that corresponds to it. But inverse sine of square root of 2 over 2 based on this wouldn't have one answer. It would have, I've got 3 answers listed. How many total should it have? It should have 1 if it's going to be a function. But if you do it this way, it's going to have an infinite number of answers. So, is inverse trig a function? No, but also yes. Inverse trig is a function because of how they restrict it. If I looked at an inverse trig graph, specifically, let's say I want to look at the graph of sine inverse. Actually, more accurately, I'm going to write y equals sine inverse of some x. If I graphed this based on what I was seeing with this up here, let's say I want to graph it where my outcome is in degrees. Sine inverse of 0 is 0. Sine inverse of 1 would be 90. Sine inverse of 180 would be 0. And my graph would look like, if I keep doing this, that. What's that kind of look like? It almost looks like a regular sine graph, but going vertical instead of horizontal. Because the way that inverse functions work, the way that inverse functions are related, is they are a reflection across the line y equals x. They are a reflection across a diagonal line. And when I take a sine function and reflect it across a diagonal line, it starts to look like this. This is not a function as drawn. This does not pass the vertical line test. This is not actually the true graph of sine inverse. Because in order to make sine inverse a function, what they did is they took this graph and they truncated it. They truncated it to where they would get all possible values of things that could fit within the domain. The domain of sine inverse goes from -1 to 1. And in order to get all values between -1 and 1 on the x-axis, and to have one continuous area where the graph exists, they chopped up this inverse sine function. That's what truncated means. It means to chop off. And they said, if I want all values between -1 and 1, the easiest place to mess with it is to get rid of this and to get rid of this. Making the range of sine inverse to be between -90 degrees and 90 degrees. The outcome values that inverse sine will give you will only ever be between -90 and 90. Or, if you're working in radians, -pi/2 and pi/2. So, that brings back to the question, or to the problem that we started with. The problem I pointed out in the fact that if I'm trying to use inverse trig to solve for an angle, I should only have one angle that comes out of it for it to be a function. But there were multiple values in which I got square root of 2 over 2. There's an infinite number of values, an infinite number of angles that will give me a result of square root of 2 over 2. So which angle is the correct angle? If my range for sine is between -90 and 90, that means that on my unit circle, 0 to 90 is easy to see. -90 would be like going down here, because remember, angles typically go counterclockwise. If you go clockwise, you're getting negative. To get to -90 degrees, I'd be going down here. So, if I am trying to look for sine inverse of square root of 2 over 2, I can use my unit circle and say, where in this area is sine square root of 2 over 2? And if the answer is down here, I don't write this angle, I find its negative coterminal angle. Where is sine square root of 2 over 2 in this region? What angle? 45 degrees. Because sine is the y values, and the y values are square root of 2 over 2 right here at 45 degrees. Because everywhere else on the unit circle is not within the proper range. 45 degrees, or if you were working in radians, that would be pi/4. Okay, what if I want sine inverse of -1/2? If it's negative and sine is y values, I'm looking at negative y values. So I'm looking down here on my unit circle. In this area, sine is -1/2 at 330, but it's 330 between -90 and 90. So the circle says 330, but we want coterminal to that. Subtract a full circle, 360, and we get -30 degrees. What is -30 degrees in radians? If 30 degrees is pi/6, -30 is -pi/6. Now that works for sine, but here's the thing. Sine cosine and tangent have different domains and ranges. In order to get all the proper values for cosine and tangent, we have to do things a little bit differently. Now, let's say I want to talk about cosine. If I do cosine inverse with all of its possible values, similar to how I did sine, cosine, biggest value is 1, smallest value is -1, so cosine inverse, its x values are going to go from -1 to 1. That piece is the same. Cosine's typical period is 360 degrees, which means I'm going to put that along my y-axis this time. Cosine inverse it's going to start up here. And it would look like this. I want to reach all values between -1 and 1 for my truncation, for where I'm going to cut this off, for where the experts chose to cut it off. Unlike with sine, when I'm dealing with cosine inverse, while my domain actually is the same, it's going to hit x values between -1 and 1. That's what I can plug in. The range is going to be different, because if I talked about from -90 to 90, the only x values I would hit would be between 0 and 1. I'd only get positive values for cosine. I want both positive and negative. So for cosine, they chose to truncate it by getting rid of that and getting rid of this, giving the range to be the values between 0 and 180, including both. Or if you're working in radians, between 0 and pi. Knowing that information allows us to do things like use our unit circle to figure out what cosine inverse of -square root of 3 over 2 is. Because if my range is between 0 and 180, then on my unit circle, I'm just looking at the top part and just straight up using those angles. Whereas cosine, -square root of 3 over 2. Cosine's the x value, whereas x, -square root of 3 over 2, between 0 and 180. 150 degrees, or if we were working in radians, 5 pi over 6. Now here's the thing. I could do the same thing for tangent. Would you like the easy way? Yeah, let's talk about the easy way. Because the easy way, significantly easier. The easy way doesn't actually require that you know the range of sine inverse or of cosine inverse or of tangent inverse. Tangent inverse, by the way, domain is all real numbers. Range is between -90 and 90 degrees, not including both. That being said, you don't actually need to know that. Today you're going to see 4 different types of questions. How you approach them is going to be slightly different from question to question. going to start off with a question we've already answered. It's the question we just answered. We know what the answer is already, but we're going to do it the easy way. Find the exact value in degrees and in radians of cosine inverse negative square root of 3 over 2. Y'all got calculators, right? Can you type in cosine inverse of square root of 3 over 2? Guess what it tells you? 150 degrees. Do you think your calculator knows the range of sine, cosine, and tangent? Yeah, the calculator knows the range. Use the calculator. The shortcut is using the calculator. Now, the calculator is going to tell you in degrees unless you have it in radians. If you have your calculator in radians, it's going to give you an ugly decimal. It's going to give you an irrational decimal because radians has the pi on it. So, if I want the answer in both degrees and radians, the calculator will give me degrees. You need to convert to the radians. Here's the thing, these numbers are going to be on the unit circle. Find 150 degrees on the unit circle and tell me what the angle is in radians. 5 pi over 6. Ta-da. This is the easiest of the problems.
Do they get really hard?
No. They get harder. They do not get really hard. Okay, here's the thing. There are two different ways to reference inverse trig. There's the way you're used to with that little -1 almost exponent looking thing. But there's another notation for inverse trig. And it's to put the arc in front of the trig that you're doing. Arc sine is equivalent to sine inverse. Arc cosine is equivalent to cosine inverse. Arc tangent is equivalent to tangent inverse. You get the point? You do the same thing. You start by typing it into a calculator. What is inverse sine of 1/2? According to our calculator, 30 degrees. And in radians, what would that be? Pi over 6. I can do inverse trig of the reciprocals too. Cosecant's the reciprocal of which one? Sine inverse. If you want to do inverse trig of a reciprocal trig function, you reciprocal that, and you're golden. Reciprocal of cosecant is sine inverse. We'll finish this when we come back. Of a reciprocal function. You do the reciprocal of the reciprocal function and the reciprocal of what's inside. So, 3 over 2 square roots of 3. You do not need to rationalize the denominator in order to do inverse trig of this. What do you get? We got some errors and we got some 60s. Did you type it in correctly? If you type this in as sine inverse of 3 divided by 2 square root of 3, Your calculator understands PEMDAS literally, which means it will understand 3 divided by 2 times the square root of 3 in the order that PEMDAS goes. PEMDAS, parentheses, exponents, multiply and divide are done together from left to right. It will do this. 3 divided by 2 times the square root of 3. Is that the same thing as that? No. If you've got multiple things in the denominator, make sure they go in parentheses. Put the parentheses around that 2 square root of 3. Then if you type it into your calculators, you should all get the same answer. Is it the 60 or the error? 60. What's that in radians? Pi over 3. Okay, I've got one more like this, and then I'm going to show you the other instructions you're going to see, because I told you there's going to be 4 different sets of instructions you're going to see. Oops, that's supposed to be negative. Cotangent inverse, negative square root of 3. There's not a cotangent button. So what am I doing? Tangent inverse of 1 over negative square root of 3. Or you can put the negative out front. And what do you get? And in radians, this is one of the most common mistakes that I see people do. Negative pi over 6. For some reason, why did I write 3? For some reason, one of the things that I see people do when they have to convert it over to radians is they find the coterminal first and then convert. Don't do that. Just straight convert. Okay, that's one type of instruction you're going to see. It's real simple to work with. Requires typing into your calculator. Okay. Next set of instructions. We'll say solve. We're going to round to the nearest 100th degree. Hundredth is how many decimal places? 2. 100 has 2 zeros. 2 decimal places. You should know how to solve these already. We did these back in 12.1. What's the only variable here? Theta. How do you get rid of sine to get at theta? Sine inverse both sides. Sine inverse this side, you'll be left with theta. Sine inverse this side, and you've got sine inverse of 0.25. Round to the nearest 100th. .14. You tell me 0.5, it's wrong. That's rounding to the nearest tenth. 4/8 degrees. Okay? Cosine of theta is equal to -2. The only variable involved is theta. To get at theta, I'm going to take inverse cosine. On this side, I'm left with theta. On this side, I've got cosine inverse of -2. What's my answer? Calculator's giving you an error. What's the answer? It is not undefined. It's no solution because my question asked you to solve. It didn't ask you to simplify. Simplify, you got undefined. Evaluate, you got undefined. Solve, it's no solution. Okay. Third set of instructions. Evaluate. Round to the nearest thousandth. Nearest thousandth, how many decimal places? 3. 1,000 has 3 zeros, 3 decimal places. Sine of arctangent of 3/8. Thoughts on how to do it? Type it in the calculator. Sine. Where's arctangent on my calculator? Tangent inverse. Rounded to the nearest thousandth. 0.351. Tangent of cosecant inverse of 7/4. Okay. Tangent's easy enough to find on my calculator. How do I do cosecant inverse again? Sine inverse of 4/7. Rounded to the nearest thousandth. Hint, 0.696. One more example of this, and then we're going to talk about the last set of instructions. How do I do sine of arcsecant of 5/6? What am I typing into my calculator? Sine of, I'm hearing inverse cosine of 6/5. Your calculator should say domain error. My answer is not no solution. I didn't ask you to solve. Undefined. Because cosine inverse does not have 6/5 within its range. 6/5 is bigger than 1. Or sorry, within its domain. You should technically probably know the domain for sine and cosine inverse. Those are important ones, but it's not the end of the world if you don't. Okay, last set of instructions is different. The last set of instructions requires a different approach. Most of what you're going to do today is really just a matter of typing it into your calculator correctly. You probably noticed that when I said, when we started doing the shorter version, and then everything was calculator based. These instructions are not. The key thing with these instructions as to why this is not a calculator based problem has to do with the fact that it's telling you that theta is between 0 and 2 pi. Between 0 and 2 pi is not the range for any of our inverse trig functions. Sine goes from negative 90 to 90, including both of those angles. Tangent goes from negative 90 to 90, not including either of those numbers. And cosine goes between 0 and 180. None of them work for the full circle. But I just gave you a hint right there. 0 to 2 pi is what the angles that fit on the unit circle. This is a unit circle based problem. It'll be similar in idea to kind of how we started some of the problems before we just kind of recognized that we could put it in our calculator. To do inverse trig using the unit circle, if I do not tell you this range, you need to know the range of the inverse trig. If I do tell you this range, I'm just saying every single value on the unit circle is fair game, which means I'm finding every angle in which sine is negative square root of 3 over 2. Sine what part of the unit circle? Y values. Look for the y values of negative square root of 3 over 2. Found 2 of them? There are 2 of them. What are they? 240 and 300. So close. Nope. Look at what I told you about the angles. They need to be between 0 and 2 pi. 4 pi over 3 and 5 pi over 3. They should be in radians. Tangent inverse, square root of 3 over 3. Where's tangent on the unit circle? Yeah, we added it to the outside the other day. So I look at those numbers. Tangent needs to be square root of 3 over 3. At what angles? Pi over 6 and 7 pi over 6. Cosine inverse of 2. Is cosine ever hitting 2 in the unit circle?
No.
Think about the graph. What's cosine's typical amplitude? 1. It typically goes 1 above and below the midline. It goes 1 above and below 0. Does it ever actually hit 2? No. So the answer is? Did I ask you to solve or did I ask you to evaluate? It's undefined. If it doesn't say solve, it is undefined. If it says solve, it's no solution. Final example. Oh, that's not what I meant to do. It works. How do I do secant inverse of 1/2 again? Do cosine inverse of 2 over 1, aka 2. Which I wrote down the wrong thing. We already established this is undefined. So, if it tells you the range between 0 and 2 pi, you're using your unit circle. Otherwise, you're using your calculator. We're on page 856. 11 through 29, 34 through 39. It looks a lot longer than what it is just because it's all calculator stuff. Almost all calculator stuff.